I'm R. Prabha, Assistant Professor in the Department of ECE, SNS College of Technology. In this video, we will discuss the topic on shift registers SISO, SIPO for the course Digital System Design. So, in this video, we are going to discuss the contents are hazard-free circuit design, shift register fundamentals, SISO, SIPO detailed design, and its applications assessment. And now we are going to see the recall of the previous topic, hazard-free circuit design. So the hazard are the unwanted transients, and there are two types of hazards. One is static hazard and another one is dynamic hazard. So in the static hazard, the output momentarily go during the input transitions. And in the dynamic hazard, there will be oscillating outputs during transitions. And because of this hazards, there will be unwanted switching transients. So we need to eliminate this. So elimination method by carefully selecting the logic design and also the simplification techniques like K-map, we can use hazard elimination and we can find out hazard free circuit. And if we apply design thinking in hazard-free circuit, first we may need to understand the problem in hazard circuits. So in the hazard circuits, we must understand what are the type of hazards, and after finding the hazard problem, we have to find out the creative solution. And creative solution we use logic simplification by using K-map method. And after that we have to prototype that is the circuit implementation, and next we have to check or test whether there will be hazard eliminated and the circuit is hazard free circuit. And now the shift registers. So shift registers are essentially the memory storage devices, and we are going to discuss the shift registers, the two types: serial in, serial out, serial in, parallel out. And now we are going to discuss in design thinking way. So in the empathy part, we have to understand the need of shift registers, and here the shift registers are there are storage devices in memories, in communication systems and also computer systems, etc. And it consists of a series connection of D flip-flops, and here one flip-flop output being served as an input to another flip-flop, and in this way there is a cascade architecture is having. And this sequential circuit, each flip-flop connects to the next flip-flop, which creates serial data paths. And next is the serial in, serial out design and SISO design. And in this ideate part, we are taking four D flip-flops, and common clock is shared by all the flip-flops, and there is a clear signal to all the flip-flop is connected to in order to reset the flip-flop before starting the operation. And one flip-flop output is connected as an input to another flip-flop. So here the input enters serially after each clock pulse. One flip-flop output will be transferred to other flip-flop. So after nth clock pulse, all the outputs are at the last flip-flops. And now the next type of flip-flop is serial in, parallel out shift registers. And in serial in, parallel out shift register, the input is taken serially, but we can take output in parallel manner. And this is very much useful in serial to parallel communication. So in this case, we have the four inputs. As we see, one flip-flop output is the input to another flip-flop, and at the junction the output is taken. So in this way all the outputs are taken. So here also the input enters serially, that is the input enters bit by bit, but we can take the output in a parallel manner, and after nth clock pulse all the data are available. And there are various applications of shift registers. It can be used as a data storage device, communication purpose, transferring the data from one device to another device, and very much useful in signal processing applications, counter designs, and storage devices, everything. And now, the so far we have discussed about the hazard-free circuit design and the shift register fundamentals. The two types of shift register we have seen: the serial in, serial out, serial in, parallel out. And now the assessment questions. We can compare SISO and SIPO according to the operation and also the architecture. And the hazard deduction, we can use Karnaugh map, and the design thinking concept can be applied to hazard-free circuit design and also the serial in, serial out, serial in, parallel out shift registers. References. Thank you.